A gas station sold 152,000 gallons of gas in a week when the cost of gas was $2.70 per gallon. A week later, the price fell to $2.60 per gallon and the number of gallons sold by the store increased to 164,000. Find the rate of change in sales with respect to cost and give the correct units. Okay, so as we read this question, there are two things that we can see quite clearly. One of them is the amount of gas that's sold by the gas station each week. And that seems to depend on the cost of the gas, because when the cost of the gas changed, the amount that was sold changed as well. So the amount of the gas sold, that's the dependent quantity. Okay? Dependent quantity here is the amount or the volume of gas, whichever word you want to use to describe that, the amount of gas sold in a week. Okay, so that's a dependent quantity. We said that that seems to depend on the cost of the gas. Okay, so the independent quantity would be the cost of a gallon of gas. Cost of 1 gallon of gas. Okay, so the amount that the gas station sells depends on the cost of a gallon. Okay, well, dependent quantity, we usually call that Y, and the independent quantity we call X. Okay? Right, now the question is to find the rate of change. The rate of change of sales, to be precise. Okay, so the rate of change is delta Y over delta X. That's the formula that we always use for rate of change. Okay, so delta Y, that's the final value of Y minus the initial value of Y divided by the final value of X minus the initial value of X. Okay, so it's always the final minus the initial. Well, if we look back here, Y is the amount of gas sold in the week. So how much gas was sold in the final week? The amount of gas in the final week sold in the final week was 164,000. And in the first week, the amount of gas sold was 152,000. Okay. XF on the bottom, XF minus XI. X is the cost of a gallon of gas. Well, in the final week, F standing for final, in the final week, the cost of a gallon of gas was $2.60. Minus, in the first week, XI, X initial, the first week, the cost of gas was $2.70. Okay, so let's do that. Calculation. 164,000 minus 152,000 is 12,000. And 2.60 minus 2.70 is negative 0.10, or negative 0.1. Now 12,000 divided by negative 0.01. The positive divided by a negative is a minus. And then to divide by 0.1, we add a 0 at the end, at the right hand side. So 1, 2. And then we had 1, 2, 3 zeros. So now if we're adding a 0, we're going to have 4 zeros. Okay, and then put in the 1,000 marker, the comma. So it's negative 120,000, which seems strange, but we'll try and explain it in a second. Okay, we also had to make sure that we had the right units. Okay, well, if you look at the formulas that we had, on the top we had Y, and Y was the amount of gas sold in a week. And the amount of gas sold in a week was measured in gallons. So we have gallons on the top, and on the bottom we had the cost of a gallon of gas. Okay, the cost of a gallon of gas. The cost of a gallon of gas was measured in dollars. Okay, so this is dollars. So we put our units here. Okay, when we're trying to figure out the units, we figure out the units of the top line, the units of the bottom line. So it's gallons over dollars. Okay, So that means this is negative 120,000 gallons per dollar, because when we talk about units, over translates into the word per. Now what does it mean? Okay, it's still a sort of a bizarre statement. Okay, the rate of change is negative 120,000 gallons per dollar. Well, what it means is if the cost went up, so if what's on the bottom increases, so if the dependent variable, or the dependent quantity, which is the cost of a gallon, increases by 1 unit, and that in this case means $1. The independent quantity, which is the amount of gas sold, in a week, would decrease. Now, the reason for the decrease here, the decrease comes from the negative sign. So if the bottom increases, the bottom decreases. Okay, that's the negative sign. It would decrease by 120,000 units or gallons. Okay, so that's the answer to the problem. The reason I've written it this way, if the dependent quantity increases by 1 unit, and it's always 1 unit, okay, if the dependent quantity increases by 1 unit, the independent quantity would decrease, because of the negative sign, by 120,000 units. Now if you take this sentence, you should be able to apply it and decipher any rate of change question. Okay? Now obviously we're assuming that the rate of change, that the relationship between these two would be unchanged, but you might find that that's not the case. In fact, in this situation, I'm sure it definitely wouldn't be the case, but based on the data that we have, this is the best we could do. Okay? So if the dependent quantity, in other words, if the cost of a gallon increased by 1 unit, or $1, the amount of gas sold in a week would fall by 120,000 units. Okay? Alright, well, listen, thanks for watching, and hopefully you'll be able to take this example and apply it to other examples, because that's really where the power of this rate of change is. Okay, thanks for watching and sticking through.